Hello, Math 2. This is Mrs. Bricky, and this little lesson is going to focus on interval notation and domain and range. We're going to start with some inequalities, though. You should be familiar with how to graph these inequalities from prior math classes. If you don't remember 100%, that's okay. I'm going to refresh your memory, but hopefully you've graphed things like these before. So our first inequality is x is greater than -5. So when you see a greater than or less than symbol, that boundary is going to get marked with an open circle. So I'm going to put an open circle at -5. And then we want to mark the part of the number line where x is greater than -5. So we would sketch our graph to this side of that boundary value. So this would be all of the x values that are larger than or greater than -5. So for x is less than -5, we would still have our open circle at the boundary of -5, and we would shade everything that is lower than or less than -5. Now, sometimes that boundary circle is filled in if the inequality includes the equal part of it. So this is x is less than or equal to 2, then that would be a filled in circle. We would say that the 2 is included. In the prior two examples, we would say that the -5 is not included. So for this last inequality, x is less than or equal to 2, we would fill in a filled in circle at that boundary value of 2. And then we want to show all of the numbers that are less than 2, so we would draw our graph to this side. So these are segments. They don't have an arrow on one side. It's just a little segment that's between two numbers. So if you need to write this as an inequality, what you can do is write down those two boundary values, and you can put your x right in between. On the left side, x is greater than or equal to the -3. It's facing this way because the x is greater than, so the x is on the greater than side of that symbol. And then for this side, the x is less than or equal to 2. They both include the line under the inequality because they are included on both sides. You'll notice that the two inequalities are facing the same direction, and for a segment like this, that will always be true. So for this next one, our two boundary values are 1 and 5. And both of those are strict inequalities because we have open circles there. And then our last one, boundary of -4 on the left, boundary of 0 on the right. Our x value has to be between those two. And let's see, on this side, strictly greater than -4. And on the other side, less than or equal to 0. Again, you'll notice that the inequality symbols are facing the same direction because x is greater than -4, so the greater than side is by the x, and x is less than 0, so the less than side is by the x. Okay, so that hopefully was just a review to refresh your memory. In Math 2, we need to learn a new type of notation called interval notation. And interval notation is an alternative way to express an inequality. It's a way of expressing a set of numbers. So in inequality notation, this graph would be with the inequality notation of -4 less than or equal to x less than or equal to 3. Or in other words, x is between -4 and 3, included on both ends. So the way that we would write this in interval notation is like this: -4, 3, and this particular one would use brackets. So it's kind of telling you the lower bound and the upper bound separated with a comma. And the brackets tell me that the two end values are included, like with those filled in circles. When we write interval notation, we always write it from least to greatest. So on a number line, it's from left to right. When you're using interval notation, it's not always a bracket though. Sometimes we do use parentheses. So if it's open circle or not included, we would use a parenthesis. If it's an included value or a closed circle on a graph, we would use a bracket. So I have a little example right here. 2 is less than or equal to y is less than 6. So this inequality would transfer into interval notation as bracket 2 comma 6 parenthesis. So on the 2 side, we have a bracket because the 2 is included. On the 6 side, we have a parenthesis because the 6 is not included. So we're going to translate each of these inequalities into interval notation. So the first one has a boundary from -1 up to 3. On the -1 side, it's not included, so I use a curved parenthesis. On the 3 side, it is included, so I use a bracket. Our next one is the interval from 0 to 17. So we write in our two boundaries. On both sides, we need to use a bracket because they are both included. And our last one is between -8 and -5, and both sides are not included, so we would use parentheses. So this particular one, it looks a lot like the point -8, -5. But just like with the language arts, there are sometimes things that look the same, but they mean different things. And you can tell by the context which one it means. So sometimes when we talk about parenthesis, -8, comma, -5 parenthesis, sometimes we're talking about this point on the graph. Other times we're talking about this inequality between -8 and -5. And again, the context will tell you which one it is. All right, so we're going to write each of these graphs in interval notation, and we want to always write our interval notation from left to right, from the lower value to the higher value. So on this one, we have a bracket, -5. So it starts at -5, and the upper bound, the ending value is 4. Those are both included, so I use square brackets on both sides. Our next example is the interval from 6 to 10, and the 6 is not included, so we'll use a parenthesis on that side. The 10 is included, so we'll use a bracket. Last one, the interval from -8 to -1, we're going to use parentheses and parenthesis again because both of those end values, both of those boundary values are not included. All right, well, we started out looking at graphs like these ones. So I want to think about how to write these in interval notation. Remember, when we're writing interval notation, we think about the graph from left to right. So this first one starts at -5, not included, so I used a parenthesis, and it goes up to, well, it's got an arrow. It goes up forever. So the way we would represent that is with an infinity symbol, from -5 to infinity. And on this next one, I can see that the boundary value is 2, so the upper bound is 2. But where does this start? Well, it starts at -infinity. So our interval would look like this, from -infinity up to 2, with the 2 included. So when you're looking at a number line, if you have to use an infinity, it's a -infinity on the left and a positive infinity on the right, just like the negative numbers are on the left and the positive numbers are on the right. Also, whenever you're using an infinity symbol with interval notation, you always use a parenthesis. We never use a bracket. Infinity is an idea, not a number, so we can't include it. We just have to show it with a parenthesis. Okay, so let's try to convert between some different notations now. So this first inequality is x is less than 3. We practiced graphing things like this a second ago. So we've got an open boundary value at 3, and x less than means we're going to shade all of those numbers that are less than 3. So in interval notation, this would be from negative infinity up to 3, and we would use a parenthesis on the 3 because that 3 is not included. Okay, for this graph, I'm going to write the interval notation first because I like interval notation. So we've got our left-hand side is -4, and that's an included value, so I use a bracket. And on the other side, it goes up to 1, and the 1 is not included, so I use a parenthesis. So on the inequality for that, again, when we're writing a segment as an inequality, we want to sandwich our x in between the two values. On this side, it's including the -4, and on this side we are not including the 1, so we just use a regular less than symbol. Okay, this one gives us the interval, so to graph it, it's all of the numbers from negative infinity up to -2, and the -2 is included. So this is our graph. To write that as an inequality, it would be that these are all the numbers less than -2. So x is less than or equal to -2 because our boundary value -2 is included. Okay, our last one. Let's write the interval notation first. Our boundary value is 0, so it's from 0 to infinity. To write that as an inequality, that would be x is bigger than 0. 0 is not included, so it would be strictly greater than 0. All right. So the reason that you learn interval notation in Math 2 is because we are going to be starting graphs, and interval notation is used to describe a function's domain and range. You've probably talked about domain and range before in your classes, but you may not remember them. So the domain of a function is the set of all the inputs for that function. So the domain, if we're looking at a graph, we would look and focus on the x-axis to figure out the domain of a graph. The range of a function is the set of all resulting values or outputs for that function and its domain. So the range is the y values. So if we are looking for the range of a function, we're going to focus on the y-axis. So first, we're going to only look at the domain of these two graphs. And you can see that I actually even removed the numbers from the y-axis because I wanted you to just focus on the domain values. So when we write domain, we write it from least to greatest or from left to right on the graph. And I'm going to highlight a little bit to help you focus in on the numbers, but it looks like the graph is starting here and it swoops up and over. So I highlighted the part of the x-axis that our function covers. So if we were to write that domain, it would be that it is starting at -3 and it's going to infinity because we've got this arrow going off to the left. So in theory, if I zoomed out on my graph, that would just keep continuing on its path forever. Okay, so for our next graph, again, I'm going to pull out my highlighter. It looks like it starts right here at this -5, and it goes over until it reaches that 4 value, and then it stops. So if we were writing the domain of this graph, it would be from -5, and I included the -5 because that has a filled in circle right there, and then it goes up to 4. And the 4 has an open circle, so I'm going to put a parenthesis. That is an ugly parenthesis. Try again. That's better. Okay, so for domain, I focused on the x-axis. I focused on x values. For range, same graphs, but this time I've removed the numbers on the x-axis so that we can really focus on the y-axis. For range, we want to focus on the y-axis and the y values, or the output values. So the lowest point on this graph is 2. We want to write range from least to greatest. So on a vertical number line, that would be from the bottom to the top. So this graph starts at 2 and it goes up and up and up forever. And again, if I zoomed out on that graph, I would see it continuing up. So I don't want to say it like stopped at 8 or anything, because it does keep going. So if I wrote the range of this, it would be from the bottom to the top. And the top is that it's going up forever. Okay, for this next function, or this next graph, let's see, let me get my highlighter again. So you want to think about bottom to top, and we're not thinking about the end values necessarily. We are thinking about the bottom. This is the lowest point on the graph. So our bottom is here at -2, and the highest point on this graph is 6. So our range is all the numbers that are in between those two. So my lowest value, -2, up to my highest value, 6. Now, you can probably see why I included the 6. There was a filled in circle there, and so it's included. If you have a function like this where it appears that it touches and then turns around like that, go ahead and include it. That we would consider an included value, unless you saw something like an open circle there. If you saw an open circle there, then you would not include it. But if you don't see an open circle there, then go ahead and include it if it touches and turns around. So on those last graphs, I had it separated. It's actually a little bit trickier when you're looking at the whole coordinate plane, like this one. So I have one more example where I have separated it, and then we're going to try some where it's on the coordinate plane with all of those numbers present. You really have to train yourself to look at the appropriate number line for each of the domain and range. So for domain, remember that we're focusing on the X number line, and for range, we're focusing on the Y number line. This particular function that I have graphed is a decaying function, so I just wanted to talk a little bit about its behavior. On the right-hand side, it is approaching but never crossing the x-axis. So in other words, this graph is flattening out, and it's just you probably talked about these last year in 9th grade. They're called exponential. This is an exponentially decaying function. Okay, so for the domain of our function, I kind of highlighted that whole number line, but it definitely starts right there. So this function is starting at a value of 0. The domain starts at 0. That's a filled in circle, so it's an included 0, and it goes to infinity. Always use a parenthesis with the infinity. For the range, I highlighted the whole number line, so I'm going to erase a little bit. The highest is definitely that 6 right there. The lowest, remember we said that it is approaching but never crossing the x-axis, so that means that the lower bound is 0. So again, we want to think about the range from bottom to top. So the lowest value is 0 and the highest value is 6. Because it never touches that x-axis or crosses the x-axis, that's going to be an open parenthesis there, not a bracket. On the 6 side, on the top, though, that is a bracket. We do include that 6. Okay, here's our first graph where we've got all of those numbers. If it helps you, use a highlighter to help you. Okay, for domain, I'm going to think about it from left to right. So the farthest to the left is right here, and it goes over. So my domain is from 1 to infinity. The 1 is not included because that's an open circle on that end, on that left side. For range, we think about from the bottom of the function to the top of the function. So the lowest value here is an arrow. So that's going to be from -infinity negative infinity on the bottom, positive infinity on the top. So from negative infinity up to 5. And that is also a parenthesis because that boundary on the top is the open circle. So if we were writing these as an inequality, which sometimes we need to do, this would be our x value is greater than 1. For range, though, we would need to use a y value or a y as our variable, and the y has to be less than 5. Okay, for this one, we want to write our domain and range in interval notation. So for the domain, it looks like the right side starts here all the way to the left side. So our domain is from bracket -6 to 5, both ends included. Okay, for range, we're thinking about the lowest to the highest. Well, the lowest is here, so from 1, and the highest is here, so from 1 to 6. And you do want to list that from bottom to top. Both ends included. Remember, if it looks like it touches and turns around, go ahead and include that. All right, we're going to write this in inequality notation. For domain, we are thinking from left to right. Whoops, too far. Actually stops at the -2, doesn't it? So the domain would be, and I'm writing it as an inequality. So from -5 to -2, put the x in the middle. Included on the left, not included on the right. For my range, I'm focusing on the y-axis. The lowest is -4, and the highest that graph goes to is -1. So the range would be between -4 and -1. This is a y value because it's a range value. Let's see, on the -4 side, that's open, so that one's strictly less than, and on the other side, it's a filled in circle at the height of -1, so that one's included. All right, so that is it. You have learned all about interval notation and domain and range. Thank you so much.